Well, hello guys. We're just going to do a short little video, let you know where I'm at on the 60 and how much progress I've made. We'll come back to this here in a minute. We've got transformer mounted, the blocks put back in place. I've got them all filled in with new caps. Now, one of the reasons for a lot of disconnection, well, for one thing, this is some of the old speaker wire that'll have to come out of here yet. But I dismantled the radio a little more than what you normally would, partially or mainly because with having to put a new transformer in, the original transformer in here, the filament winding, the 6.3, was center tapped. So the tap went to ground and either side went to the filaments on each one of the tubes. Well, the new transformer, the replacement one, isn't center tapped, so one side has to go to ground and the other side will then daisy chain through to all the different tubes, the other 4 tubes. So that means one side of their filaments have to hook to ground. So I've got to disconnect. This one was already disconnected because this is where it first started the chain. But I have to go in here and connect one side of those to ground, and then I can hook up the filament winding. It's not a big deal. The original reasoning for taking a filament winding, center tap it to ground, was to reduce hum, but this radio has a younger sibling. It's the 610, which is came out about a year later, and it uses the same exact tubes. The only difference is its filament winding, the 6.3, is not center tapped, so they're running those tubes as you would normally see, where one side goes to ground, the other side is hooked to the transformer. So and those radios work just fine. So anyway, I got to get that done yet. Of course, I pulled out a lot of the trimmers so I could get the IF transformers out, because this one here had to have a new grid cap lead hooked onto it. And you can't take the cans loose. If I can come in here, these are basically riveted in place, and not like a rivet. The can itself is the rivet. It's so you don't take them loose. So anyway, the top side is not too bad. Now again, the transformer actually sets at a 90-degree turn to the way the other one was, and the only way I could make this one work that way would be I'd have to cut into the chassis, and I don't want to do that to make room for the wires. I never know when I might run across another chassis that is, has no cabinet and the chassis is in real bad shape, but could have a good transformer on it. Same chassis I could use as a parts chassis, and then I'd just clean that transformer up. One thing I wanted to talk about just real quickly was some interesting differences that are not documented with these radios. Bob over at B. Anderson TV, he did a series. It's in his playlist on a 60. Philco 60, and it's the console model, where this is the baby grand model. But let me see if I can move this around just a little bit so I can get down here and show you. I was looking over it the other night and watching it, and by the way, the other video I told you that when it came to those coils, that check out his playlist. And for some reason I thought it was on part 4. It's actually like part 10 or part 9. So I'm sorry about getting that screwed up. Anyway, when he started rebuilding or cleaning up and reworking and lubing his tuning condenser, I noticed some differences between his tuning condenser and mine. Now his is actually a later run than this one, which means technically it should be a little bit newer chassis. One of the differences was there's a kind of like a planetary, it's more like a planetary bearing set instead of gear set. It's a reduction. When you turn this shaft, you'll turn it several more turns completely around than what will actually turn the tuning condenser. And it's because there's 3 ball bearings in here that this rides against, and then they are hooked into the center shaft. It gives it reduction. Well, to get them out, there's this tension spring here that holds this cage on, or this shield on, that holds the bearings in place. On his, it has 2 screws that provide the tension. You tighten, the tighter you tighten the screws, the more this push down, tighter pushes on the bearings. This one only has 1. That was one difference. The other difference is he was talking about his rubbing, and he had on the stationary plates, so you got the rotary plates here. These down in here are stationary, they don't move. Well, on his stationary plates, he actually has screws where mine are riveted in place. His has got screws that's got a little bit of adjustment. You loosen the screws up and you can move them stationary plates side to side, and probably up and down a little bit too, but side to side. That's the way they used to do actually older tuning condensers. Then later they started just riveting them in place, and you couldn't do that anymore. And the third difference is the adjustments here. These here, his adjustments kind of look like well, like the patterns that's on the back, like this. They've got a bolt that comes up through, then there's a nut, and as you tighten the nut down, the bolt stays stationary. As you tighten the nut down, it'll push the plate down a little bit, and you increase the capacitance, loosen it up, and decreases it. And it's a locking nut. This one, it's opposite. You're actually turning the screw or the bolt, and what they did was to give it a little something to put like a 1/4 inch drive on it, is they soldered on nut heads on here. So and actually the movable plate is underneath this. So I thought that was kind of interesting how there were some differences. Now getting back to what we was looking at when it first came on, both of the coils, the antenna coil and the oscillator coil, was had a bad, well the oscillator or the antenna coil would be called the primary, and it's actually only for the shortwave. Anyway, it had several openings. Here's just one piece of the wire. I seemed to manage to lose the rest of them. These are the little plastic pieces that they put over the secondary, and then wrap that them coils around. You can see they kind of deteriorate and go bad, and that's generally the main cause for the wire to get an open in it. The here's the where we wound this one. It's about 7 turns, and I put on a new piece of plastic on there and glued it down, and then wrapped the wire around, and of course then kind of glued it down too. But anyway, the oscillator coil, it has about, well, I counted 18 turns when I took it off. I was looking at Bob's video on his. He went ahead and rewound his because it was actually wound. Someone had already fixed it once before, wound it in the wrong direction. But he said something about 17. I got 18 when I took it apart. Now it was broke, and just at the end here and at the end at this end in two places, where this one actually came off in about, I think it was 4 or 5 pieces. They're actually a little different size wire. Here's the what's the remains of the wire that came off the oscillator. This will be the tickler coil. This is what drives the oscillator from the tube. Anyway, I made a crude drawing and showed the direction from the bottom, starting at the beginning pin of where the wiring started at this end, on this end right here. So that would be, on this case, this here, and then it starts and goes around that way. Whereas on this one, it starts off the ground lug here, and you can kind of see which direction it goes. So then I drew my drawings, and as I took them off, as I went across each point, I would make a mark. So anyway, that's what those are. These are generally the only things that there's ever been any talk about, and it's just these windings here that seem to cause problems, and it's mainly because of this shield, plastic shield. As it deteriorates, it probably either outgasses a little bit, or it may even just shrink or expand a little bit and break the wire. I'm not sure which. So anyway, that's where I'm at. Those are done. IF transformers, these don't generally have any problems with the windings. It's just those coils. And if you just got, say, this coil, for example, the antenna coil, if this is the only, it's the only one that's bad, and it's just got this little 7-turn winding bad, all you don't have is shortwave. Your broadcast will work fine. So anyway, now on to another problem I ran into. When I messed with the speaker initially, I think the only thing I did was to actual measurement was just the primary of the audio transformer. I might have went ahead and went clear across the audio transformer and the field coil and seen a total resistance there and thought, well, that looks about right. But I don't seem to remember actually measuring the field winding, so I thought it was time, maybe I ought to really seriously check it and make sure it was alright. I knew the cone needed some serious attention. It had a few holes in it and some previous repairs that were badly done, so the cone needs some serious attention. But when I got to looking at the field winding and started cleaning it up, it started flaking, falling apart. As you notice, it is rather black. Well, the field winding is the AC choke, so a lot of current had went through this when it burned up the transformer. So it's not really surprising that this thing started burning up. And as it is, it's supposed to measure somewhere around 1140. It measures like 925, and then that will change when it was all together if you just kind of pressed on it. So it's gotten hot enough that some of the windings in here, the enamel has been burned off and it's shorting some. So it's done for. Here's some of the flakiness of the paper and burnt paper that was on it. So I dismantled it. I took out the cone, which needs, like I say, needs some serious attention. Now these can be taken apart. Well, taking out the cone's not a big deal. Acetone will take loose the glue around the edge unless it's been glued with something else, which in one spot it was, and I had a hell time with that. But the rest of it was factory glue, and acetone will quickly deteriorate, take loose that glue and soften it. But as far as getting the frame off, they have what is known as, well, the proper name is drive rivets. Drive, like you drive a car, rivet. But a lot of people call them screw rivets, mainly because they've got like a twist in them, a thread like in them, and as you drive them in, they twist in, and then it basically kind of screw themselves into place. So they're not flattened over on one end like a regular rivet. And these can be drove right back out real easy. I started off with a brass punch just to get them started, because that's usually the hardest part, is getting them started. And then once I got them started, then I went down to a pin punch that was just a little bit smaller than they are, so I could drive them completely through. Well, they fit into this plate. Now this plate is kind of a semi locked, riveted onto the main frame here. Yeah, I do have a coil in there, because I found myself, I had a speaker that had no cone, no nothing. It's not a Philco, but it's got a little bit higher resistance, so it's going to lower the voltage some, but inductance, it should be about the same. So and it fit, but it kind of fit a little loose. So if I can get this thing back out of here, I've got it fitting in there nice and tight. Don't know if I can do this. Yeah, I can. Okay. But here's the coil, and what I did to get it to fit a little tighter was an old cap, electrolytic Ajax cap. These are one of the cardboard tubes that's over top of a metal can. So I just slid it in half, cut it down a little bit, and fitted it over there, and it makes out just enough makeup for the looseness of the coil. So now it fits on there nice. This part right here is where your voice coil runs over. This is the pole. And then this would mount on here, like so. This is your humbucking coil here. It wanted to start unraveling, so I put a little tape on it. Then there's a insulating shim that goes in there, and then this will let's see, yeah, sits down like this. No, the other way. And then you drive it back on. You just drive that off, it'll come off fairly easily, and it'll drive right back on just fine. And then once that's all together, you reset it back on the frame, and then drive your rivets back in. They'll drive right back into the holes, and you're good to go. So I'll be able to get that thing up and working. And the cone, like I said, has got some definite needing of repair. I've done worse. I've had worse cones than this, so this is not really that big of a deal. And it's not like it's a high fidelity radio anyway. It's a radio from the mid-30s. So anyway, that's where I'm at. I've got the electrolytics rebuilt and shined up. They're just the top parts. I just cut right down through here. The top part is just stuck into the tube for right now, and the clamp will actually hold them good enough. I've never really ever had to glue them. So anyway, I wanted to give you an update and let you know what was going on and what I found, and my proposed fixes for it and stuff. So in the next video, I'll have the speaker back together. I may try to well, I think I got one radio I could probably, a Philco radio I could hook it up to, and see about getting it, testing it out. And we'll be continuing on plugging away. I rewired the wiring on the transformer. They weren't really bad, but they were short. And some of these wires have to go long ways. Like one of the primary side leads got to come clear up here to this point here. That's where the volume control and switch hooks and stuff. And and then there's like one of the filament leads has got to come clear over here, snake its way over and hook into here. So the wires are actually longer than what they need to be, but that's perfectly fine. You can always cut wire off. Trying to stretch it's not the easiest thing. So, but since I did need to lengthen them, and I thought, well, I'll just go ahead and just, you know, put new wires on it and go from there. So I don't really know of anything else I want to tell you. One little thing, I'm going to throw my 2 cents worth in. I don't know for a fact. For sure, I'm just going by a lot of pictures I've seen. You can find lots of pictures of these chassis and these radios. They were quite numerous, and they had a long run in the mid-30s. So it's not hard to find a lot of pictures of these radios. And so I've looked through a lot of pictures and stuff. If you notice, there's 5 holes. Well, these coincide with these trimmers. All right, they bolt on the back, and then you stick a 1/4 inch drive through there to adjust them. 2 of them have plugs. The rest do not. Now, I've looked at these here with a magnifying glass. These are metal plugs. When they snap in, they're going to leave a little bit of mark on the chassis. I cannot find no marks, nor pretty much any picture I've ever seen, they didn't have plugs in some of the holes. Only certain ones did. Well, these 2 happen to represent the 2 trimmers that are on the IF's primaries. These guys here. Well, these are got B plus across them. Alright, because your B plus line's running up here, so you've got, you know, a couple hundred volts or so across those. And if you're sticking in something in here, or if you're just messing around with the chassis, or just somebody goofing off or whatever, if it didn't have a cap on it, there's a possibility of either them getting shocked or shorting it out to the chassis or something. So those are understandable why they got plugs. Now, I think the difference between color, I think this is original. I think this is the first IF primary, and this is the second IF. I think that's why they denoted the 2 different colors. But the rest of them, this is the secondary of the first IF. It just goes across the grid circuit. It has like, you know, maybe minus a couple volts on it, you know. And these 2 are adjustments for the low end frequency on the oscillator. One's for broadcast band, and the other one's for what they call the police band or the shortwave band. And they're also in the grid circuit of the oscillator, so they don't have much voltage. It'd be about -8 to -10 volts on them. The worst case scenario, you short them out, they just shut the oscillator off. That's all they do. So they don't need to have caps. So I think from the factory, this is the way it came. I don't know that for sure. I'm just making an educated guess on that. So anyway, that's about all I've got for you. I thought this was going to be a short video. Sorry it's not. But we'll be getting this thing back together. I want to let you know that they can be, certain ones can be. Now there's some that are fully riveted in. You know, that they don't have these style rivets. But Philco liked these, and I like them because you can take them out and you can put them back in. Not like a dozen times, but you know, once like this is perfectly fine. So I'll be working on that. I want to clean up the frame, the cradle, the basket while I got it apart. It's got a couple little rust spots on it. On the outside it's not too bad, although there's one, no, okay, there's one right there and one right there. So I want to clean it up. I got to get what's left of the paper off of here that did not want to come unglued, and clean it up, and I think it'll clean up really nice. It's only got like a couple little dinky rust spots. I'll probably also, before I put this together, clean up the pole there. It's kind of got a little dirt on it, and get it cleaned up. And I think that's about it, and I'll just put her back together and test it, and it should work just fine. Get these coils in place and continue on from there. So I want to thank you for all your comments. I did get on there and answer some of them, and stuff. And anyway, I guess that's about all I've got. So I'll be seeing you guys on the next video. And again, if you like the video, give it a big thumbs up. If you're new to my channel and you like this kind of stuff, I do everything just with, it's vintage electronics, mainly pretty much entirely on tubes. I do talk about theory also and how they operate. So if you like that kind of stuff, you're new to the channel, and haven't subscribed yet, please subscribe. That way you'll know when new videos are coming out. So anyway, I guess I'll see you guys in the next video, and we'll show you our progress then. Thanks again.